Okay, good afternoon everybody. Thanks for sticking around, those that have, appreciate it. My name is Morgan Brody and I'm a returning international student, so that's why I have to commit until today. My chosen topic is called Automated Bottle Filling Station, and it's made up of 5 units. First, there's an in-feed conveyor, then you've got a transport conveyor, filling station, capping unit, and an out-feed conveyor. And the purpose of all that is to produce this. So the bottles will start off without a cap. As you can see, they'll move along, be filled up with water, caps will be placed on, and caps will be nice and tight at the end. Just gives you a quick view of what's going on. Why did I choose this? I chose it because it's a practical topic. I like practical things as opposed to other topics. It's industry related, so this is the kind of thing that I'm going to see, hopefully when I get a job very shortly, along with everybody else. And it's a real life engineering problem, and there isn't really a better way to prepare for a job than to do a proper problem. I'm sure you guys have seen this in the labs, maybe not. We'll just go give a bit of a background on this. This was originally acquired back in 1993 for the Campbelltown campus, UWS. And it was meant to be part of a larger production facility which basically involved all kinds of distillation tanks, industrial PLCs, valves, pumps, sensors to produce any sort of consumer good. And it was part of the technology and management degrees over in Campbelltown. Now unfortunately this was never really operational from the information I was given. So in 2003, it was brought here to the UWS robotic lab, just down the hall. And since 2003, it's remained non-operational, despite a few attempts by groups of students. So then we'll just fast forward 15 years to today. And what we've got is modular design, right? Each unit is made so that it can be used by itself or as a group with other units. You've got your in-feed conveyor, your out-feed conveyor, filling unit, capping unit, and then the transport conveyor. Modular design is what everybody sees now when it comes to automation because it's very flexible. And the great thing about all this is that it works off of 240 volts. So we could take any one of those units, bring it in here with the air compressor, and it's going to work. Which makes it very cheap for any young entrepreneurs or smaller startup companies that just want to make maybe a couple thousand bottles a day, not a million like Pepsi or Coca. The first unit is the in-feed conveyor. This is made up, the tabletop is about 1,200 millimeters in diameter. It's made of high-density polyethylene, which is fancy for saying semi-hard plastic that's easy to clean. It's controlled by a motor mounted underneath, and the motor travels the tabletop in a counterclockwise direction, and is variable speed controlled, so you can have bottles coming in fast or quite slow. There, in the video, it's about 50%, I think. And there are 3 guides shown, and each of the guides, what they do is they allow the bottles to be mounted or placed in the center, and then as the table rotates, it funnels them so that first there's 2 or 3 bottles, then there's a single bottle to go on the transport conveyor. The transport conveyor, it's the one that links everything together. So without it, the automation of this whole station wouldn't really be possible. You need to have that. It's also variable speed control, and it has hand adjustable rails, so you can easily, within 5–10 minutes, adjust for any size of bottle. Right now, as I show you, we're using this, but you can use probably up to about 15 centimeters width or diameter, depending on the container. After the transport conveyor, we're on to the filling unit. Could have done a presentation just on this alone. It's controlled and operated wholly by pneumatics. Okay, so what that means is that you've got your valves mounted underneath. You've got pneumatic timers, which range from 0 to 60 seconds. And you've got some AND OR gates. There's a control panel for easy operation. You have your usual on-off switch, E-stop. You've got a adjust and run switch, so that if the operator needs to adjust the filling volume of a container, they can flip that into adjust, and the stroke cylinder will go forward, allowing you to adjust the fill volume, no problem. There's also a gate delay and a buffer up delay. The whole thing is easily maintained. Just a couple weeks ago I took everything apart, replaced some seals, added some lubricant. You don't need any special tools, and I assume anybody can do it. It's pretty good. In the lab we've got a 50-liter hopper mounted on the top, and it sounds like a lot, but it lasts not even 10 minutes when everything is going. So you have to have somebody filling it up pretty regularly. There's 2 interchangeable product cylinders. In this video I'm using the smaller one, the 250 mil. It's about this wide and this round in diameter. There's another cylinder, 1250 milliliters, which is quite a bit bigger. They're both the same length. The fill volumes are adjustable from anywhere from 3 mil all the way up to however large your product cylinder is. I think you can get a 2-liter product cylinder. After we're in the filling unit, the bottles are filled now, it's onto the capping unit. And here, the only unautomated thing about it is an operator has to take the cap out of the box and just lightly place it on the cap and maybe just barely start those threads. Okay, afterwards it goes along, it'll be clamped. As you can see right there, there's some gates that allow 1 bottle forward at a time. Now, if there's no cap present, the optical sensor won't count. It won't sense a cap, so it will not continue. A cap has to be present. The chuck, there's a rubber chuck that's used, this guy here. That's interchangeable depending on the size of the caps you need, and it will need to be replaced probably every, I don't know, 5,000 to 10,000 caps. The rubber does wear down. And, although this is operated by pneumatics, the whole thing is controlled by a timer unit. And the timer unit is located to the right of the capping unit. It controls 1 sensor and 2 solenoids, so the optical sensor and then 2 solenoids. Those 2 solenoids control right now 6 cylinders, but it can be accommodated up to 10 cylinders depending on what you're doing. There are 4 presets for the timer. There's P1 and P1 plus R, and what they control is the air motor and the cylinder that extends the air motor down. And they control how long the air motor is on and when it should switch off. Then there's P2 and P2 plus R, which control the clamps and the gates. The gates are normally extended while the clamps, obviously, are retracted. Once they're actuated, they switch. So the gates come in, clamps move forward to firmly hold the bottle as it gets capped. And finally is the outfeed conveyor, which has all the same characteristics as the infeed conveyor. 2 main differences being that it goes clockwise and that there's a wedge on the side. And the wedge, you see the wedge, what it does is it moves all the bottles towards the center of the conveyor to allow for the operator to remove them for packaging, and it prevents any bottles from colliding with those coming off the transport conveyor. What was done? It's nice just to fit this in 1 page. Each unit was first inspected. All the issues, missing and broken parts, were documented. Any parts, if needed, were ordered. fix and replace components. There was testing, troubleshooting, fine-tuning, and final testing documentation. Some of these steps were repeated numerous times to get things working the way they are now. Issues along the way was, of course, missing parts, components, and hoses, and broken parts, components, and hoses. And there was zero documentation with this from the beginning, which made it very difficult and brought the whole unknown factor quite high. It's just basically, here you go, fix it with nothing. Recommendations. Usually you need about 2 operators to work something like this. One operator is going to load on the in-feed conveyor, that person is going to also unload, and that person is most likely going to fill the hopper with product. Your second operator is the one who gets the awesome job of putting these caps on all day. So their job is to reach in the box, put this cap on, and repeat for however long the shift is. Because of that, I recommend getting an ergonomic mat for that person to stand on, maybe even a chair. Obviously both operators can probably switch every hour, just so nobody goes out of their mind. Take that step one step further. You can replace the capping operator with the MotoMan, excuse me, robot that's in the lab right now. That MotoMan has been there from way back when I began. And it's remained almost in the same position, so I know it's available. It's not going to conflict with anyone, and it's free. It's there for us to use. It'd be a great future project for any upcoming students, 3rd, 4th year. It's easily programmed, and I think the person doing it would learn a lot, a great deal. My recommended layout for that would be something like this, where you've got, on this side you've got the bottles coming in, right? These are the bottles. Obviously here at this point it's going to be filled up. This is going to be some sort of part feeder, where the caps would line up, most likely on a slope, so that gravity would just feed it, nothing fancy. You'd have a sensor to say, yes, there's a cap available, and you'd also have another sensor to say, yes, there's a bottle here waiting to get a cap put on it. And once those 2 conditions are true, then the MotoMan is just going to go through its pick and place routine, pick up a cap, move around, and just slightly squeeze that on. The only thing that I see that would actually cost anything would be to make a mount for that MotoMan, because the one it's on right now is just a bit too long. My conclusion would be, right now everything works perfectly, that I'm pretty happy about. This unit is intended for small scale production, but having said that, you could squeeze out a few thousand bottles a day, no problem, because when it's going, like I said, it uses 50 liters in less than 10 minutes. So you'd be up quite high numbers for that. You can adjust the cycle times from anywhere from as slow as you want. If you want to do 2 bottles a minute, sure. Probably up to a maximum of 30 bottles per minute, depending on the fill volume and the size of your container. This is extremely flexible. It works with a variety of container volumes, so pretty much you could, the gates on the in-feed conveyor are all movable. They move either way. So you can have large containers, small containers. The only thing that limits you is the size of the width of the transport conveyor. Like I said, you get about 15 centimeters there. You can package pretty much any commercial goo. We're looking at honey, shampoo, toothpaste, hair gel. I'm not sure about corrosive stuff, such as motor oil and that. But as far as the consumer stuff that you guys would use every day at home, this machine is going to package it. I only used water during the testing and everything for a few reasons. It's free, readily available, and it's really easy to clean up. I can't imagine doing this using honey or shampoo or something. It would be a nightmare. And one cool thing that came out of all of this is that a local company contacted me and was actually wanted to buy this from the uni, which I thought was kind of neat. And there you go. So, are there any questions as you watch the final video?
What happens if there's too many bottles in the final to make things like
In the
what happens
outfeed?
in there?
Yeah, this isn't, it's not designed in a way that a monkey could use it. Like similar automation systems you find in factories where it doesn't matter. There has to be some sort of human input, awareness to see, okay, there's too many bottles here, we've got to remove them, kind of thing. Yeah.
So there isn't like a fail-safe in case if there is no one to watch it?
No,
Okay.
no. No, there isn't.
So
The
if
bottles
they
are just-
head up to the pub or something like that, then there's going to be bottles as well.
No, actually no, because if they head off to the pub, then there'll be no one putting caps on.
With like reset up, just say you wanted to have a Magnum instead of a normal 750ml wine bottle or something like that. Is there a reset up for height of the capping and filling and things like that? Because
Yeah,
there seems to
there's-
be very little clearance on those
there's,
bottles.
On that filling unit, there's I can't remember how much, there's at least 30 centimeters of available travel. And you can adjust the nozzles that are used for that. Right now they're quite long, they're about 20 centimeters, but you can get them shorter, and you can also get them in different diameters.
That's cool.
Yes?
In that scenario you just mentioned, if there wasn't enough caps, now the sensor, sorry, no one's putting caps on, the sensor on the capping device would detect there were no caps, and it would say, I'm not going to do this bottle because there's no cap on it.
Yep.
What about the filling device? Does it also detect that this bottle's already been filled?
After yesterday's little demonstration. What'll happen is the bottles will stop right here, but there's no cap, and they'll keep going. The filling unit's gonna keep going, but the bottles will eventually line up to the point where the bottles can't go any further on the filling unit. So the whole conveyor is just gonna get filled up, and the filling unit won't go anymore because it's spaced so that when it's full, all the bottles line up with the gates.
So if the bottle, if the just filled bottle doesn't move on because of the backlog,
Yeah.
it won't try to refill it again.
It might. It's not, it's not the smartest machine in the world. The bottle presence sensor is this ancient little whisker pneumatic flicker switch, and it's not very, there's no feedback on that. If there's a part present, it's going to continue to fill, regardless if the bottle's already full.
Would you say that the capping unit is kind of a negligible item considering the person's already got to pick up the cap, half put it on?
I thought
You
that.
just twist it 2 more times and put it on there.
I thought that, and then I took not half a day, I took maybe 15 minutes till I got annoyed, and I put on every cap nice and tight. And in one way it isn't necessary, it's a bit overkill, but on the other hand, putting a cap on like this thousands of times a day, just, I don't think you're going to get anybody that wants to do that job, to be honest. It's possible.
We're if we would.
But you've got to make sure it's tight, and the capping unit does a great job of that.
Is there a similar station to put caps on, like your filling unit and that, instead of using a robot arm and someone else's time for the next?
I would think so. I would think so. I just chose the Motoman because it was in the lab. It's available. And yeah, and I understand that it's overkill to do something like this, but
But it's efficiency, isn't it?
it's efficient, and that's what we've got, right? Yeah. Yeah. You could build a much easier device to put the caps on, for sure. But the motor has it doesn't cost any money.
It will be used. John, when you come in, your motorman's gone. Okay, thank you very much.
Okay.